Hello, sorry this video came out a little late. We had a lot of people who were still taking the practice test for surface area, so I didn't want to put out the solutions yet. But as soon as you finish the practice test for surface area, you can watch the solutions. If you actually wrote your answers down, you can go through and see exactly what you did wrong. If you guys are printing out the practice test like we would normally do in class, you'll find this pretty helpful. So by the way, I guess I'll go ahead and say this test did not go very well. I'm not going to show what the class averages or anything like that are. We typically would do that, but keep in mind we're not really going through our normal process where we take our quiz, like our pop quiz, and then we go over the problems you guys missed on the quiz. Usually on the quiz, if you remember, we average about a 65, which is pretty terrible. But then we go over the things that we're missing on the warm-up. We have entire days where we do review, where the assignments are based on the problems that you guys were missing on the quiz. And then we take a practice test. You see how you're doing the second time through, and then you can study that. And then we finally take the test. And by the time we take the test, you've seen those problems a lot on the homework, on the warm-up, and on the practice test and the quiz. And then we end up averaging, if you remember, we were averaging about 90% on our test, which is absolutely phenomenal. So we go from a 65 to a 90%, and it's all about our process for remediation and review. So if you don't do as well as you normally would do on these tests, keep in mind that's because it's a practice test, and because of the nature of how much time we were given, because we lost 2 weeks at the beginning and 2 weeks at the end of the 9 weeks, we've had to cut all of our review and our normal procedure and our warm-up and stuff like that. So this is just to kind of see how you would have done if you took the original quiz kind of cold turkey. But keep in mind, normally we would be going over these problems and reviewing and remediating all throughout the beginning. All right, so 2 minutes in, and I'm finally going to start the first, but I thought that was important so you guys don't get so upset or sad about how you're doing. All right, so number one, and know that I'm not disappointed because these scores are not going to look too great, but I'm really honestly I'm not disappointed because these are pretty tough problems, and I guess you just need somebody to explain it to you and over and again, and that's what we normally do. There's a reason I do what I do. So number one, circle A has a circumference of 36 pi inches. What's the radius of circle A? So our formula for the circumference is 2 pi times the radius. So we want to know, they give us the circumference, which is 36 pi, and we want to know what the radius is. Well, how do we relate the circumference to radius? Well, it's 2 pi times the radius. So first thing I'm going to do is write the equation down, plug in the value for the circumference. So I'm going to rewrite the equation as 36 pi is equal to 2 pi times the radius. And I want to solve for the radius, so I have to divide both sides by 2 pi. Whenever I do that, I get 18. So my radius is just simply going to be 18, which would be C as in Charlie. So 26% of you guys missed this problem. So that means 74% of you got it right. So overall, this is pretty simple. It looks like a lot of you guys picked A. Let me see. So I'm not sure if A is where you divided 36 by pi as well. I think that's what it is. But keep in mind when we divide pi here, the 2 and the pi, both of those cancel out, and the pi is going to cancel with the 36 pi. So let me check that real quick. I think that's what's going on. So if we do 36 divided by 2, and I'm going to do pi as well. So this is like if I forgot to put pi in the numerator. Yeah, that's exactly what you did wrong. So 21% of you guys just didn't notice that little fact there. So I could probably draw that out real quick. All right, yeah. So anyway, those two would end up canceling out all that just for that, right? Okay, so that's number one. Let's look at number two. It says find the arc length of xpy. So arc xpy, remember we start at x, we go the shortest distance to p, and then we end up at y. So it's kind of like a segment xy, but we need a third point in order to define it, like defining a plane well. That way we know if we're referring to the semicircle, the minor arc, or the major arc. So starting at x, go the shortest distance to p, which would be going counterclockwise against the clock, right? and then go all the way around until we get to y, and that's going to be the end of our arc. So you want to know what's the length of this part here. So right off the bat, the 90 degrees is not what we're going to use. We're going to use the 270 degrees. So we have to do 360 minus 270. So if you got it wrong, that might have been what you did wrong. You used the 90 instead of the 270. So you got to be careful. This is not the minor arc XY, which would be this part here. It's XPY, which tells us it's the major arc. All right, so just using the arc length formula, all we're going to do is find the fraction times the whole. So our fraction we're going to use is basically 3/4, but I'm going to go ahead and do the 270. And then we're going to divide that by 360. And then we multiply it by the length, which would be 2 pi times the radius. If this is 8, that would be 16 pi. So I can go ahead and leave the pi out. No, because it wants to see how I don't have pi in my answer. That means I need to go ahead and multiply pi. All right, so that'll work. And it's going to give me 12 pi, but yeah, I guarantee that's what a lot of people missed. Yep, sure enough. So the reason for that is that our answer is 12 pi, not just 12 meters. And so we would have to convert it to a decimal, which would give us about 37 point, or the nearest whole number would give us 38 meters. So the correct answer would actually be Charlie on this one. Ouch, Charlie, that really, yeah, that just happened. Okay, so most of you guys missed this because of that fact there that you forgot to multiply it by pi. So do be careful. Most of the time we just leave the pi out and then we put it in our answer. But if you notice these didn't have the answer, it's because they want it rounded to the nearest whole number, not pi meters, but just meters themselves, okay? So I know, really tricky, and if I showed you that mistake on a practice test or a quiz and a warm-up, you probably would never make that mistake again. And that's the whole point. We just want to learn from our mistakes because we are human and we're definitely going to make mistakes. And I made this test last year and I might have made it a little on the hard side, but that's okay. It's good for you. You're in honors. All right, so find the diameter of the circle. Again, this is bold and italicized because a lot of people are going to find the radius and forget to double it at the end. Sure enough, that's what a lot of people missed, and 69% missed this problem. So arc length formula here, plug in the value for 13 for the arc length and the 67 for the x. So that's going to look something like that. Now we're talking. All right, so first thing I want to do to solve for radius is I have to multiply by the reciprocal. So divide by 67, multiply by 360. Of course, we're doing it to both sides, so this part's going to cancel out. So where's my handy dandy calculator? That's going to be 13 times 360 divided by 67. Okay, so 69.85 roughly. So 2 pi r is 69.85. And again, this is an approximation, so I'm using approximately equal to symbol because that's how they're related to each other. And then I got to divide both sides by 2 pi. So you just put that in the calculator. When you do divide it by 2 pi, if you click divide by 2 and then you hit pi as well, that's only going to divide by the 2 and not the pi itself. It'll actually multiply the pi. So you have to divide by 2 and then hit divided by pi again, or use parentheses, or use the fraction button. So if we want to use the fraction button, I can paste that, put it in the denominator, 2 pi, and I'll get the exact same answer as I did before. Okay, so if you got something else, I guess I'll show it because that's probably what you guys did wrong. And if we did this and we said divided by 2 pi, we're going to get a number that's very different, much larger, because it's actually going to divide by the 2 and then multiply by the pi. So if that's what you got, which luckily was not one of your answer choices, but it's just because you put it in the calculator wrong. So anyway, we got a radius of 11.2, so that's our answer, right? Nope. A lot of you guys missed that because it asked for the diameter. So if our radius is 11.2, the diameter would be 22.23. And of course, those approximations, all we do is we take our answer that we got here and we multiply it by 2, and that'll give us 22.23. Okay, so actually most of you guys got that right except for these. Maybe that one was a guess. I'm not sure. I did make the distractors, but I don't remember off the top of my head what each one of those meant, unfortunately. Okay, so a bicycle tire with a diameter of 0.24 meters, so that's going to be 24 or 200, no, yeah, 24 centimeters, because there's 100 and that's 100th, yeah, wow. Okay, diameter rotates 2,000 times during your ride to school. How far in miles do you live from the school? So first thing we want to do is find the circumference. So 2 times pi times the radius. If they give us, or we can actually use pi times diameter because that's the 2 in the radius there. That'll be shorter. So it's just going to be 0.24 multiplied by pi. So 0.24 pi, which will give us a decimal. We do want to change it to a decimal because we're not working with pi in our answer, so we want the decimal. Now that's going to be how far we travel in meters every rotation, but the tire rotates 2,000 times, so all we have to do is multiply this by 2,000. So that's how many meters we traveled on our way to school. And then they tell us that the conversion factor, 1 mile is 1,609 meters. So all we'd have to do to change this to miles is divide it by 1,609, which would leave us with the decimal, which would be, when we round to the nearest hundredth, would be B as in Bravo. So most of you guys got that one right, so that's good. If slamming a car door can be heard from 1.4 miles away, and there are 1,382 people per square mile near the car, then how many people could hear the car door slam shut? First thing we want to do is find the area. We're not dealing with circumference, we're dealing with area, so we need to take the radius and square it. So 1.4 squared. I should have color coded those, but that's okay. So 1.4 squared, just take my word for it. I'll save myself some time by not putting it in the calculator, but 1.4 squared is 1.96, and then pi. But because we don't want to deal with pi in our answer, we need to go ahead and multiply it by pi to get it to a decimal, which is approximately 6.16. Now that's how many square miles worth of people can hear the car door slam. So then we need to multiply this number by how many people are in each square mile near the car, and that'll give us our final answer, which is going to be, apparently it's 8,510 people. I can show you how to put it in the calculator, but it just takes a lot of time, and I think that one's easy enough. You can figure it out. All right, number 6, find the area of the circle. So this one could be a really tricky problem, but I only made you do the first part. So we were doing problems on the homework. Remember the back side, the part that you guys just like wrote the answers on, and some of you guys didn't like set up the problem. Well, it caught up to you. So find the answer. So find the area of the circle. So they give us the area of the sector, which is this part here, which relates to the 224. And remember, that's the fraction of the whole area. So what is that fraction? Well, the fraction is the x out of the 360, right? Which would look like the 224 out of 360 times the whole area is going to be equal to the sector, the area, right? So the part, our sector is going to be equal to the fraction times the whole thing. That's our whole formula. So if I want to find out, working backwards, I want to figure out what the whole thing was, all I have to do is multiply by the reciprocal of our fraction. And that should make sense, right? We can undo a fraction by the reciprocal of the fraction when we multiply. So if I put that in the calculator, it's just going to give me the answer. Anyway, so the area is going to be 38.09, and that is our answer, which is D as in delta. Okay, so it looks like most of you guys got that one right, more than any other answer choice, so that's good. Then the further steps, which we're not doing on this one, but if we wanted to solve for the radius, is what I would ask for. We'd have to divide both sides by pi. Okay, that would give us the r squared, and then we undo a square with a square root, which leaves us with the radius there. So that's typically how we would do these problems, but I only asked you to find for the area of the whole thing, so all you had to do is undo the fraction. So we do 360 divided by the degrees that the sector was in, and that will give us the area of the whole thing. So it just kind of undoes our original formula. All right, number 7. John needs to paint his capsule. So surprisingly, only 33% of you guys missed this. So some of the easy problems, just following the formula, you guys actually did really well. So that's good. And this actually was kind of a harder one because you had 2 different parts. You had the sphere and the cylinder, and you had to add them together, but only the lateral area of the cylinder. So I'm impressed. You guys did well. That means you understand the concepts, and the problems we're missing are just gotcha questions, honestly, and small mistakes. So anyway, you guys are doing well. So first, find the surface area of the sphere. That's going to be 4 pi r squared, which remember was the lateral area of the cylinder. So like if this sphere, if it fit snugly inside the cylinder, the lateral area, those two would be the same, which is kind of cool. So radius, in this case, they give us a diameter of 10, so the radius would be 5. 5 squared is 25 times 4 is 100. So if that came out nice, you can actually do all that math in your head. Sometimes I nice. All right, then we want to find the lateral area of the cylinder. So that's the circumference times the height. Circumference in this case is pi times diameter, which would be 10 pi, times our height, or distance between the two parallel bases for the cylinder, which is 17. So 17 times 10 pi is going to give us 170 pi. Now to find the total surface area, we just add these two together. Again, you could do that in your head. It's just 270 pi. So our answer should be B as in Bravo. And most of you guys got that one right. So good job. So find the area of the kite. Surprisingly, only 19% of you guys missed this. I didn't even give you the formula, which means you understand how to find it. You either remember the formula or you just found it by area by deconstruction, which is what I bet most of you did. Well, in a kite, remember that they're perpendicular. It's actually, remember the kite's like the creepy uncle or whatever for the rhombus. And so this is the first one where that property actually came in with quadrilaterals. It actually started out with the kite, which is pretty cool. So perpendicular diagonals, meaning all these are right triangles. So you can find the area of each one by multiplying 8 times 5 divided by 2, and then 5 times 13 divided by 2, and then you're going to end up doubling it because you got 2 of them anyway. So you could just do 8 times 13 multiplied by 5, which is what I would do. Or you could remember our formula. And our formula goes like this. So if we take the diagonals, which is 8 and 13 is 21, and 5 and 5 is 10, and we multiply the diagonals, that would give us the area of the entire rectangle. But if you notice, we don't want the area of the entire rectangle. We want just the area of the triangles, so which is going to be exactly half, right? So this is half the area. This is also half the area, same as that one. And so is that half the area and half of that. So if we multiply the diagonals, divide by 2, that'll give us the answer that we're looking for. So that's going to be 21 times 10 divided by 2, which is 105. So good job. Looks like some of you guys that missed this, maybe you just Charlied out. That's possible, but it's kind of funny. Also could just mean that you forgot to divide by 2, right? So you did 5 times or 10 times 8 plus 13, which would be 10 times 21, and you forgot to do half because we're dealing with triangles. But that's okay. Find the area of the regular pentagon. So this one you guys struggled with. We only spent 1 day talking about the area of regular polygons using apophthegms. Usually we would spend a review day, and this would be one of those topics that we go over again, but that's okay. And I could give you the formula, but you figured it out without it, so good job. So we have this part of the triangle. We have this 6.9, which might have messed some of you guys up. That's actually extra information that we don't need, because when we're dealing with the base times the height of a triangle, we use the parts that are perpendicular to each other. So this I guess you could call it slant height or whatever, this diagonal here is not going to be necessary. So we're going to end up doing 6 times 3.5, and that's going to give us the area of this triangle if we divide by 2. But the best way to do this is actually to kind of complete this here. So if we have a pentagon, each one of these triangles here are all going to be congruent. And if we do 6 times 3.5, because that's already half of the base, that'll give you the area of both of these, like the rectangle where we move part of it down here, right? So 6 times 3.5, and then we multiply that times 5, and that will give us our total area, which is going to be 105 meters squared, which is funny because that's the same answer as the last one, right? Yeah, that was kind of weird, but it worked. And I'm gonna see what some common mistakes were. It looks like the 210, you counted it twice or whatever. I'm not sure quite how you got that one. I think this is the value. That's the value you get if you multiply the 3.5 times the 6.9, doing the same process instead of 6. But again, they have to be perpendicular to each other. And then they probably guess, would be my guess. All right, find the surface area of the cone. So we're just following the formula. So we have the area of the one base, which is the green base we see here, times the circumference, which is in blue, times the slant height, which is in red. Isn't it nice when I color code everything? What if the test was like that? That'd be too easy. Alrighty, so when we plug in our values, the area of the base, 7 squared is 49 pi, times the circumference, which is 2 pi times radius, 14 pi times slant height of 15.7. All I have to do is multiply those, divide by 2, and add it to 49. When I do, I get 158.9 pi. Remember, our answers are left in terms of pi, so don't actually multiply the pi, and if you want, you can just leave them out and put the pi with your answer at the very end, which is what I would do. Oh, I gotta show you the breakdown, sorry. So looks like most of you guys got that one right. Good job. Find the surface area of the following. So we have a cylinder here. We have 2 bases now, so it's the full surface area, not half. If you look at the other one, notice we divide the lateral area divide by 2, and we only have one base, so the cone is going to have half the surface area that the cylinder would if they had the same dimensions, like height and slant height being the same as well. All right, so surface area, 2 bases. On this one, we have a radius of 20, so 20 squared is 400, and 2 of those are going to be 800. Then circumference is going to be 40 pi and times the height of 10, which is 400. So we have 800 plus 400 pi, which would give us 1200 pi. So our answer is C as in Charlie. So it looks good. On this one, I'm trying to see what you guys did wrong. I don't know. I'm sure there's some way that you could do this. Maybe you only did one of the bases and then somehow you got 80 from here. So if you did 20 times, I don't know. If I thought about it, I could probably figure out what the distractor was, but I don't want to waste any time. All right, number 12. Find the surface area for the following. Ready? So we got 2 bases, perimeter times height again. So our 2 bases are 36 times 8. I'm just going to reveal the answer. So 288, there's 2 of those. And then the perimeter is going to be 44. Oh, that's not right. That's actually 44 times 2, which would be 88. All right, I found the mistake. All right, so 88 times 15, which means my answer probably isn't going to match what you would get. So 88 times 15, and then 2 of those. So this one's actually probably doubled. So our answer should be... wow, I don't know what I did. All right, so let me get out the calculator and I'll do this proper. All right, so we have 88 times 15. So 88 times 15. Okay, that plus 288. I'm just going to add 288 again, which will give you 1896, which is the correct answer. Okay, so anyway, figure out what I did wrong, but I'm just going to move on. Looks like most of you guys got that right. More of you guys got it right than I did, so good job. All right, 13. Find the slant height. So on this one, remember we did all the Pythagorean theorem stuff, and it was so annoying because I gave you slant height when you need the height, or I gave you the height when you need slant height and stuff like that. Yeah, so tricky. But you need to know how to go back and forth between those two. And you took geometry, so you should know Pythagorean theorem. Like of all things, Pythagorean theorem and right triangle geometry, probably the most important. So on this one, we have a squared plus b squared is c squared. Now we're assuming this is a right pyramid, which means that the apex is going to be directly above the base, and if we dropped the altitude, it would be orthogonal to the base in all directions, right? So it's a segment that's perpendicular to a plane. That's what orthogonal means. Anyway, kind of cool. So that assumption would mean that if this was 6, that means that this length here, this leg, would be 3. So we'd have 3 squared plus 4 squared is equal to x squared, which is Pythagorean triple. You already know. We've seen it a million times. And we get our answer of 5. Should have made that one harder, but I didn't. All right, 14. I should have done a radical on that one. Anyway, find the surface area of a sphere with a diameter, again, diameter of 18 centimeters. So surface area, we need to take 18 divided by 2, which is going to be 9. So 4 pi times 9 squared. 81 times 4 is going to be 324 pi. All right, looks like most of you guys got that one right. So you weren't even tricked. And I'm sure the ones that missed it here would be if you squared the 18. Yeah, that's probably what that is. In fact, I'll confirm it real quick. So if we do 18 squared, so 18 times 18, and then multiply that by 4. That is how that works, right? Pi r squared. Huh. So no, I don't know. I don't remember how I got the distractor, but it worked. Haha. 15. Find the difference between the surface areas of a model of the moon with a diameter of 3.4 and a model of the Earth with a diameter of 12.8 inches. So here we have home, Earth. That's where I live, and the moon. And again, these are given in diameters. So for our formulas, we have to adjust it for the radius. So half of 12.8 would be 6.4, and then 1.7 is half of that. Now, I'm going to do some fancy algebra here because I'm lazy, but I know how you guys probably want to do it, and you just find the area of the Earth, the model for the Earth, and then you subtract the area for the model of the moon. That's totally fine, but I'm going to show you fancy algebra because that's how I roll. All right, so what I ended up doing is I factored out the 4 pi because I noticed there was a 4 pi in both terms. So I factored that out so you can see when I color code it, hopefully it shows up pretty well. So we got 4 pi times the difference between the squares of their radiuses, which is kind of cool because it's the same formula. We got that common 4 pi going on there. That keeps me from having to multiply both of them by 4 pi, which would be what would happen if I would factor that through, right? So it should make sense. So all I'm putting in the calculator is 6.4 squared minus 1.7 squared. And then when I'm done, remember I got to multiply it back by 4 pi. All right, so when I do that, I get this value exactly times 4 pi, which is going to be exactly 152.28 pi. And that will be the difference in our model, which is C as in Charlie. Good job. The other difference, this one might have been if you forgot to put these and as the radius and you did the diameters, or perhaps one of them is if you actually multiply the pi as well. Actually, let me check that theory real quick. So the 152.28, and then if we actually multiply that by pi, I think that's what this one is, then convert it to a decimal. And I said convert to a decimal. Yeah, all right, so everyone who missed this one is because you used pi twice. So you multiplied your answer by pi to get it as a decimal without pi, but then you also noticed that it was written in terms of pi. So you multiplied pi twice. So again, some really tricky mistakes, and that was the most common mistake. So what's kind of annoying about this unit and volume as well is that sometimes we ask for you to leave your answers in terms of pi. Sometimes we ask for it as a decimal, and it really just depends on the context of the problem. Like when we were talking about people, let me go back to one real quick. So like the car door slamming, right? We wouldn't talk about units of pi people, 3.141592654. We're not going to talk about pi people. That doesn't make any sense, even though that like might be like the average like house, I don't know, has like 3 people in it or whatever. That'd be kind of funny. But what is pi people? I don't know. It's like a whole nother like species of pi people. That sounds awesome. I want to be friends with pi people. Anyway, but it doesn't make sense to leave our answers in terms of pi. So we would change it to a decimal. Then we multiply it. That'll give us people, right? Also, we wouldn't have a decimal of a person. We would go ahead and round up to the nearest whole person. Same thing with how far do you live away from school? We had to multiply the pi in there because we were interested in the miles, not pi miles. But many times when we're dealing with circles and spheres, we leave it in terms of pi because the answers are nice and neat numbers and it's precise. If I put 100 pi in the calculator, I know exactly what that is, and the calculator could give me, it's not 100 centimeters squared, it's actually 314. 0.152654 or whatever as well centimeters squared. Okay, so that can be a source of frustration on this unit, and normally I'd be there to talk you through all that stuff, but because you're doing distance learning, I'm just trying to expose you guys to this stuff, which you guys are doing great. So I'm super proud. Don't worry about it, and keep in mind the other we are doing a lot more than most people are doing. We'll just put it that way. So I am glad that you guys are getting all the material, and you're not going to have a giant hole in your math education. So especially OG geometry. All right, so fun, awesome. Last problems. Made this one too. So pretty cool problem. It says, what's the area in square feet of Brian's old room? So this Brian is not like my first name at all. And so this is not a story about what happened when I moved out. My parents replaced my room with a pool table, but that's okay. Why couldn't they put the pool table in when I was still there? Whatever. So we want to find the area of the room. So we look at the dimensions here. We have 4 and 8, which would be 12, and another 4 would be 16. Okay, so if we add all these y components, that would give us 16, and 4 and 4 is 8, plus another 4 over here would give us a dimension of 12, right? They tell us the dimension of the pool table is 4 by 8, and then there's 4 feet going all the way around, right? Remember that was written in the problem. That's why they have 32-inch pool cues, or 36-inch, I don't remember. But yeah, anyway, so it ended up working out, but it was super cramped in the house, at least in the room. All right, so to find the area, we just multiply 16 times 12, which would be 192 square feet. Did I show you the breakdown on the last one? Yeah, I did. Okay. All right, so 192. Looks like most of you guys got that right. if you got this one, I think the 96 was when we forgot the 4. So we ended up doing, I think, 8 times 12 or something like that. Yeah, that's 8 times 12. So you got the 8 here, you got the 12 on the bottom, but you forgot to add the extra 8 for some reason. So yeah, you got half of the area of what you were supposed to. So I don't know how you did it, but somehow you missed it. All right, what's the perimeter in feet of his old room? So once we know this is 16 and 16, then 12 and 12, because it's a rectangle, we can add them all together. So 32 plus 24 is 58. So that would be D as in Delta. It's like most of you guys were not tricked on that one. And then area by decomposition, we're going to have to subtract the area. So we take the area of the whole thing, which was 192. That was from problem 16. And then we're going to subtract the area of the pool table because we want to know how much of the room is not taken up by the pool table. So that's going to be so 192 minus the 32 that we have here. And then we would, which is just 160. So E is an echo. And that's it. Looks like most of you guys got that. So we are done just under 30 minutes because I talked for the first 2, debriefing you guys so you wouldn't be so sad about how you guys did on the test. So just know I'm proud of you guys. We did do as well as we normally do, but we've already talked about that. You guys are doing just fine, so don't worry about it. The fact that you made it this far through distance learning and watching the videos and everything, that's awesome. So keep up the good work, and I know that work ethic is going to carry you guys to success in whatever you do in the future. So I know you will reap whatever you sow, and so all this stuff that you guys are putting in now, it's going to pay off. You're separating yourself from other people who haven't had as good of work ethic. So yeah, it's good stuff. So proud of you, and thank you for sticking with me through the whole thing. It makes me want to work harder because you guys are working really hard for me. So I'll see you guys later.